Welcome to Narayan Microwave Technologies.
This is the demo of Theorems and Laws -1 trainer. In this trainer, we have different type of experiments you can perform. Ohm's law, Kirchhoff's law. In that, you can perform KVL as well as KCL. Then we have Norton's theorem and Thevenin's theorem. So these four experiments can be performed in a single kit. This kit has one 0 to 15 volt variable DC supply. Here you will be getting the 0 to 15 volt variable DC supply. This is your Ohm's law, this is your Kirchhoff's law, this is your Norton theorem, and this is your Thevenin's theorem. And this kit has inbuilt power supply over here and one on-off switch. Now I have made the connection for Ohm's law. The connections are such that this variable power supply I have connected over here. So the supply would be given from this, and one ammeter is there, that is multimeter in ammeter mode, and 1 kilo ohm load resistor I have used. So according to Ohm's law, current would be is equal to voltage divided by resistor. I is equal to V upon R. Suppose if I have given, here you can observe the voltage. Suppose I have given the voltage around 3 volt. So let us on the switch. Check this. The voltage is around 3 volt. 3 volt. If the voltage is 3 volt, resistor is, I have used 1 kilo ohm. So the current would be 3 milliampere. That is 3 voltage divided by 1 kilo ohm. So the current would be 3 milliampere. You can observe the current over here. It is 3 milliampere or 2.99 milliampere. Now if you add these two resistors as well, and you can see the effect of adding those two resistors. Okay, now I am connecting these two resistors in series. So the equivalent resistance would be 2 kilo ohm. At this point in time, the current would be half. Previously it was 3 milliampere, now it is 1.5 milliampere. This is 1.5 milliampere. Again, if you add one more resistor over here, so the current would be 1 milliampere, since the total resistance is 3 kilo ohm and your current is 1 milliampere. So in this way you can add on the resistor or you can increase the voltage. Accordingly your current will change. Suppose I am putting the voltage is around 6 volt. Okay, our voltage is around 6 volt, resistance is around 3 kilo ohm. So our current would be I is equal to V divided by R. 6 voltage divided by 3 kilo ohm. So that is 2 milliampere would be your current. So in this way you can calculate or you can perform the Ohm's law experiment. Now similarly, I have made the connection for the Kirchhoff's voltage law, that is KVL. See, this power supply is connected over here. I have short these two terminals and I have made the two resistors in series, and here I am closing the circuit. The KVL say whatever will be the this voltage, input voltage, is equal to the sum of these two voltage across these two resistors. Okay, now let us see what is the voltage, what is the input voltage. The input voltage I have set is at 10 volt. You can set anywhere in between 0 to 15 volt. Okay, now let us see the voltage across this first resistor. This is 5 volt. Okay, and the voltage across the second resistor 5 volt. So this 5 volt plus this 5 volt is equal to the 10 volt, which was your input voltage. Suppose I have increased 10 volt to 12 volt. Now our input voltage is 12 volt. At this point, your these two voltages has to be 6 volts each. This is 6 volt. The voltage across this resistor is also has to be 6 volt. Okay, so this is your Kirchhoff's voltage law. This is for the KCL, the Kirchhoff current law. In this, the equation says incoming current is equal to outgoing current. This is your incoming current. It has to be equal to these two outgoing currents. Now let us see what is the incoming current. Incoming current is 0.010 ampere, or you can call it as a 10 milliampere. This is your incoming current. Okay. On these two terminals, you will be getting the outgoing current. Okay. Since I have used one ammeter, and here I have short it. Okay. So the first outgoing current is how much? 5 milliampere. Okay. Now let us see, or let us check this outgoing current. To check that, to short this and connect the ammeter over here. This is also the same 5 milliampere. It means whatever is the input current, it has to be equal to the outgoing current. Here we have used the two branches, so every branches flows the same amount of current, which is 5 milliampere. So if we add 5 plus 5 is equal to the 10 milliampere. Again, if you want to increase the incoming current, now it is around 12 milliampere. At this point in time, your outgoing current would be 6 milliampere each. The first one is 6. You can see over here 6. First one is 6. You can check the second one as well. First we short this. Or if you have the 3 meter, so you can use 3 meters. This is the second current. So 6 plus 6 is equal to 12 milliampere. So this is your Kirchhoff current law. This setup is for Norton's theorem. The supply is connected over here. Give 10 volt. Here you can observe the current, which is short circuit current, which is around 3.36 milliampere. Name it as ISH. Then you open and remove this power supply part and short it to calculate the equivalent resistance. And here you find out the equivalent resistance by putting this into the resistance mode. 1.5 kilo ohm is your equivalent resistance. So you have find out the short circuit current, equivalent resistance. Now you can construct the Norton's theorem. This is for Thevenin's theorem. 10 volt I have supplied to the circuit. I have short this. Then this is your output voltage, which is near about 5 volt. So this is your output voltage. Now we have to find out the equivalent resistance of the circuit. To find out the equivalent resistance, you can turn off the trainer board, remove the supply part, short it, put this in resistance mode, and observe the equivalent resistance, which is around 500 ohms. So you have observed the output voltage, and you have observed you have find out the equivalent resistance. So by using these two, you can construct the Thevenin's theorem. So these four experiments can be covered in a single trainer board. Thank you for watching the video.